all you wonderful fifth graders. You ready to do some more math? Our next lesson, we're going to do a jump. We had done 87 last. We're jumping to lesson 90. So grab your book and turn to page 586. All right, on 586, you're going to see the title there, Reducing Fractions, Part 2. We did Part 1 a little while ago, and so this is actually kind of a review for you, but it was a new concept, so it's something you need more practice at. So you're going to find it's pretty easy to do, okay? So just as a reminder, if we have a fraction, let's say that we have a fraction that's like 6/8. That is not in its simplest form yet. We have to reduce it for its final answer to be totally correct. Who decided that long ago? I have no idea. But it was some mathematicians long ago said we have to reduce this to be the simplest terms. Okay, that means this. If you remember, we talked about this before. We're going to ask ourselves the question, what is the biggest number that could go evenly into both the top and the bottom of the fraction with no remainder? So we've more recently talked about greatest common factor. We know that is the number we're trying to think of. What is the greatest common factor in this fraction of both 6 and 8? So what number could go evenly into both 6 and 8? Excuse me. Whew. Allergies. Excuse me again. Whew. Okay. So I could ask myself, what's the biggest number that would go evenly into both 6 and 8? I know that 2 will, 3 won't, 4 won't, so there's nothing bigger. So it's going to have to be 2, okay? So I ask myself, how many times does 2 go into 6? It goes in 3 times. How many times does 2 go into 8? 4 times. So my final answer is 3/4. Do you remember doing this before? You actually have done a couple worksheets on it. So this is more of that. There are a couple new things that have been added on this lesson. If you look at example 1, it actually gives you a word problem. There are 4 blue marbles and 8 white marbles in a bag. So how many total is that? 4 plus 8, 12, yeah? If one marble is taken from the bag without looking, what is the probability that the marble selected is white? Okay, so since 8 of the 12 marbles is white, the chance is 8 out of 12. So that's what the probability is, but we can't leave it 8 out of 12. We're going to simplify that. What number goes evenly into both the top and the bottom, the greatest common factor of 8 and 12? Do you think what that is? That is going to be 4, okay? So in my mind, I'm thinking, divide by 4, divide by 4, that's what I'm thinking. Okay, 8 divided by 4 is 2. 12 divided by 4 is 3. So your answer is going to be 2/3. Did we get it right? We did. Woohoo! We got it right. 2/3 is the probability of pulling a white marble from that bag. Okay, if you look at example 2, here's something else that's a little bit new that we have not done before. It's asking us to change 40% as a reduced fraction. So here's what we're changing, 40%. Write that as a reduced fraction. Well, we have to first just write it as a fraction. What do we know? We put a percentage over to make in a fraction. Do you remember that? We do 40 and it's out of 100. 40% is 40 out of 100. So there's the fraction we're going to start with. There's the fraction we're going to reduce, 40 hundredths. Once we have 40 hundredths, we can ask ourselves, what is the biggest number, the greatest common factor of 40 and 10? Do you think what that is? Yep, it is 10. So I'm going to divide the top by 10. I'm going to divide the bottom by 10. Remember, this is what I'm thinking. Ooh, you know what? It's not 10. It's 20. If I divided by 10, I'd have to reduce some more. So let's do 20. 40 divided by 20 goes 2 times. 100 divided by 20 is 5, so 2/5. Okay, now let me show you what would happen if we'd gone ahead and done it with 10. It's not a problem, we just have to reduce twice. Because if we divided by 10, we would end up with 4/10. But that, when we reduce it dividing by 2, would be 2/5. So you can see we'd end up with the same answer. But if I was dividing by 10, I wouldn't be dividing by the greatest common factor. I'd just be dividing by a factor that I thought of. Okay, so it does need to be the greatest common factor in order to reduce it completely. Okay, so that is how you're going to turn a percentage into a reduced fraction. Okay, all right. Oh, and when I look in the book, they did 4/10 into 2/5. So it's okay if you do that, but that's the best way to do it. Okay? All right, your assignment for today is on page 589. You are doing A through L. And you're going to do the worksheet. We've been doing those each day, so you have that to do also, and that's 1 through 12. On A through F, you're just reducing those fractions, putting them into the lowest terms, okay? And then G, H, and I, you have to multiply the fraction first, okay? Or add, or subtract, or whatever it is that you need to do to the fraction to start with, okay? So on G, you're going to add, on H, you're going to multiply, on I, you're going to subtract. And then once you get the answer, reduce it to simplest terms. And then J, K, and L, you're doing this. We're turning a percentage into a reduced fraction, okay? You have similar things on this worksheet, same kind of things you're doing. So you have A through L in your book on page 489, and you have 1 through 12 on this worksheet, okay? Let me know if you have any questions. I know you're going to do awesome at this.